thank you all for coming. We get ready for the keynotes, and it's like terrifying. And then you think the keynote's done, and you can relax, and then you come into an audience this big for your next talk. So thank you all for coming. I was going to be like, this will be a piece of cake. No one will show up. And here you all are. Okay, so my name's Myhill. I work at Unity, and I've got, I think, for me, the coolest job in the world. I get to make camera technology all day and listen to the forums and listen to what people are asking for and then build it and watch you guys make cool stuff. So what's better than that? Who was at the keynote here yesterday? Like basically everybody. Okay, awesome. And while we're doing the hand thing, how many people have actually used Cinemachine before? Okay, that's pretty good. Okay. So at the keynote, I had a slightly obnoxious video of myself sitting down talking about why cameras are important. And I'm gonna drill into it a little bit more because they are. And if your project has a camera, you got to get it right because people know. They know when it's wrong. This is an ARRI Flex 35. We've seen a lot of movies through this thing. This shoots on film. Some of you might not have even been alive when people were doing that. But it was real. We did it for a long time. We made a lot of movies that way. And that's heavy. That's a very heavy thing. This is a modern camera. This is an ARRI Alexa with a big zoom lens on it. And this doesn't even have a lot of follow focus gear on it. It's got a manual focus thing. So this, and it even doesn't have secondary displays and a bunch of other stuff. So this is actually a pared down camera rig. That's heavy. And where I'm getting with this is, oh, and here's me shooting with and the only reason I'm putting this in, and I know this is obnoxious, bear with me, but that's a Russian Lomo 35mm anamorphic lens, and they hot roll the glass. And if there's any lens nerds out there, there's like a handful of those in the world. It was pretty awesome to work with. So here's an interesting statistic. We watch a lot of content. We've watched a lot of movies. We've watched a lot of TV. And in watching all this stuff, we're learning. We're learning what cameras do. Okay, so why is this important at this talk right now? So everyone here has an incredible built-in subconscious understanding of what lenses do, how cameras move, how they perform, what they can't do. Cameras can't start and stop instantly. Cameras can't teleport. Cameras can't do a whole bunch of things. And you know this. We all know this. And I'm going to prove it. Watch this. You guys see these tilt shift images? It was like all a fad like 2 years ago. Thank God it's died down. I mean, this is like a form of lens flare of, this looks small, right? Why does that look small? It looks small because the focus is wrong. Now, why subconsciously would you think that's tiny town? Or this is tiny town? It's not. These are obviously real photographs. But we look and we're like, oh, cute, it's mini. But why do we feel that way? And we feel that way because in watching all of that television and all of those movies, the only time we ever see something that has that kind of focus is on things that are small. Here's a little, whatever that is, caterpillar. We've seen enough of this to know when this happens, it never happens here. Isn't that crazy? Like, I would like to take this experiment to like a Malawi tribesman who's never seen any content through a lens to see, does this look small to you guys? I'll start a GoFundMe or Kickstarter for that. The next bit is movement. This is Technovision gears. You've watched a lot of movies with this be the pan and tilt control device. And there's like people out there who specialize their entire career just on cranking the wheels and getting it smooth. That's heavy. Here's a little video of it's relatively recent, but it's like a Phoenix crane arm with.
It's made in Barcelona, Spain.
And these things are pretty popular on higher budget movies because they can. Oh, our internet's slow. Great. Don't make me pantomime what this movie does.
And it's very smooth.
So basically, yeah, okay, you can see it here. So it's a camera It's a rig, it's a head, it moves around. You can get crazy shots with it, like here they're spinning it, like anyone's ever gonna do a shot that has that many spins. But the guys who built the rig are super proud of that function. That's a true story, I'm sure. And look, there's cool, crazy things, right? That shot will never, ever be used anywhere. And this is where I'm gonna loop it back. So yeah, we're making a game and it's interactive and we can break all these rules and we can do all this crazy stuff. And 100%, let's do that. Let's break new ground and be awesome. But let's know when to do it. Because if you just do it and you don't have a plan behind it or know why you're doing it, people are gonna look at your project and they're gonna go, I don't know what it is. There's something crappy about it. There's something, I don't believe something about this. And those accumulate and they're gonna see a little bit once, they're gonna see it in the animation, they're gonna see it somewhere else, and then your game just goes down. So we built this thing called the post-processing stack. I'm gonna show you version 1 and I'm gonna show you version 2. It's amazing. And look how much lens stuff is in it. I mean, almost half of the post-processing stuff is lens stuff. And I just find this interesting, and you're my hostage audience, so I get to talk about this for a second. Twirly mustache lens designers over the course of history have been working on optical formulas to try to minimize vignetting, minimize flare, create the purest image. And in CG, we create a pure image, and then we do all this crappy stuff to make it look good. Isn't that amazing? I think that's so cool. I'd love to meet a twirly mustache lens designer and go, we're doing exactly what you don't want to do. Because CG is super clean, and cameras are clean, and there's this, the perfect imperfectness of real life, right? The clicks and pops on a record. So this is what I'm going to try to show you in 45 minutes. Look at all these demos. I had to cross one out, and that's due to a technical issue, and I couldn't get the project over. It's 2D, so I'm going to give you a link at the end of this. We'll do a 2D tutorial. Let's jump in. Let's do some camera stuff. Okay. So let's just turn this on. What is Cinemachine? How does it all work? We make things called virtual cameras, and they're not a camera. They're an idea of a camera. They're super light. And this one's pretty crappy. It doesn't have a lot of weight. And it's following his nose or his eye. And the way that it works is you make lots of cameras in your scene. I've had scenes with hundreds of cameras, and they all do different little tasks. And you turn them on and off via timeline or via code or from a thing called the state-driven camera module, which I'll show you in a second. And we have a way to blend or cut between them based on what you'd like. So when you install Cinemachine, which you can get off the asset store, but I'm going to give you a link to the latest and greatest version, which isn't up there yet, at the end. What it does is when you create a virtual camera, on the main Unity camera, you see we get this little red dot, and we hijack it, and we make a thing called the brain. And this little brain contains the blending information, and I'll get into this really quickly. Basically, if you want to create a giant state machine setup between cameras, what you do is you say, from this camera to that camera, blend over this long. From any camera to this camera, do that. So think of like Resident Evil, and you have got multiple cameras through a world, or this is super versatile. You can use it in a lot of different ways, but that's how you set up the blending. And another thing that I want to show you here is this thing called World Up Override. And I'm touching on this for a second because it gets lost and it's important. We've done the math to get the blending right. I think we're on our 5th revision now. And it's because the weight is not a lerp. Or people, just do a lerp, it'll be great. Just a lerp. It's like, no, man, there's way, way more to it. It wants to feel like a real camera guy. It wants to move appropriately. It wants to deal with gimbal lock appropriately. And it turns out that we've got different math going based on like sort of a horizon to get it to feel right. So if you're doing an RTS where you're looking up or down a lot, you can put an object in here with a rotation, and basically what that does is that twists the whole math space to line up with whatever your game is. So if you're always looking down, put an object here and rotate it down and kind of just think of it as like a sweet spot of juicy math that's horizontal, which you can bend up or down. Okay, so then what happens is you turn the camera on and you say what you want to look at. And in this case, here's just a simple composer. We're just looking at his left eye bone. And we got these screen guides, and you can move it around. You can say, okay, I want you to look, my mouse is really sensitive. I want you to look over here. Or what you can do is you can open these things up. And look at this. I'm going to open it up. And see in that little zone? The camera will disregard any motion that's in that little zone. There's like a little clear patch. And I can bring that over. And as long as the motion doesn't hit the edges of the blue, the camera won't do anything. And I'm going to tighten that up a little bit. And then we've got this stamping thing. And if we set it to 0, we get crappy, old school game cameras, where as soon as it hits, I'm going to just tighten this right up, the camera's just like hard pinned. Like, look at this, it's just perfectly following it. Or you can say, put a couple of seconds in here, 2 and 2. And now there's a little bit of a decoupling between the camera and the subject. And I'm going to tighten the field of view up so you can kind of see that more. See how the little yellow dot's coming away from the center of the crosshairs. And that's dampening, that's the weight, that's the math that we spent a long time on. This isn't the best thing to show it off, but you get where that's going. Now, you can blend between cameras that have got totally different setups. So I'm going to just turn this camera on, and we've now blended to this camera with a terrible composition. I'm just going to move the mouse over here. And then if I turn this camera off, it'll blend back to the other one. And the reason why it's taking 2 seconds to blend is, remember I showed you on this guy right here, on the brain, if you don't define anything, the default blend is 2 seconds to an ease in and ease out. See, ease in and ease out right here? I can just say, okay, let's make that a cut. And then if I turn on this camera, it's going to cut. Dunk, dunk. Or you can get sexy and go, why don't we say from, what are the 2 cameras? Composer 1.5 camera, from this camera to this camera, ease in and ease out in 1 second. But when I go back, I want to go really slowly. So now when we turn that guy on, we're going to have 1 second, oh, this mouse is super sticky. We're going to have 1 second one way. I turned the wrong guy. Okay, so we got 1 second one way and 2 seconds the other way. This is super simple, but what I want you to get here is the ability to create lots of different cameras and to manage how they all blend to each other is really easy. And this is a file. We put this as a file because you might want to have a whole different set of relationships for one scene versus another scene. Okay, let's go to the next thing. This is called Free Look. So I'm going to turn it on. Now you might be asking yourself, well, like, what's a priority? Like, am I always going to turn on the next camera? And what we have is we have a priority system. And if it's the same or higher priority, it'll go to the next camera. And if it's not, it won't. So you can actually build these really big setups where, like, a death camera is priority 10, but a running camera is priority 9. So it's going to play the running camera until something higher priority, and you can manage events like that. The next thing I'm going to show you is called Free Look. And this one's actually pretty close to my heart because third-person action-adventure run-around cameras are really fiddly to do. We spent a long time on this one. Is anyone using Free Look out the audience right now? Okay, good. Awesome. Whoa. Okay, so this is how it works. If you look into our little hero mouse on this screen, you'll see there's 3 rings. Can you guys see that? On the left. there's a ring here, low, middle, and high. And you can map to a controller or anything. And what we've done is we've built this rig where you've got control of the speed of the orbit, control of the speed of the up and down, and we've exposed the top and the middle and the bottom cameras. Example, I'm now on the top camera. I can say, no, I want the top camera to compose like, you know, like, where's my guy? I want my top camera to compose, and I want him down here. But then when I go to the middle camera, I want him to be composed in the middle. And then when I go to the bottom camera, I don't know, let's just say we want his head to go right to the top. So you just go to the bottom camera. It's right here. You can see bottom rig, aim, screen Y. You can say put him there. So now you've got this, you know, pretty lousy free look camera, but you can see how you can control those for each one. And just for giggles, let's like crank the lens up on the top. And let's fix that composition. I mean, that's terrible. Okay. So now you've got this free look rig. You can control the speed. The deceleration's too high right now. Just going to turn that down. Okay, sure. So you can really craft your free look orbit rig for, you know, running around and doing stuff. Now, I used to work at EA a long time ago with a gentleman that's actually sitting in the front row there. It's an old friend of mine. And when you wanted to make cameras talk to animations, it meant getting out of your desk, going down the hall, knocking on the door of this lead programmer's office. Hey, so can I get a camera hookup for this animation? And he's like working on some really big problem, and he just sees you as this frustrating guy. I mean, have any of you been there? Like, it's real. The struggle is real. So we built this because that sucks. We built this thing called state-driven camera. Look what this does. It's this little guy right here. So it scrubs your project, your animation, Mecanum, for states. Here they all are. This character's got a lot of states on it. Running, walking, jumping, whatever. This will scrub your project for whatever's in your states. And then what you do is the walk down the hallway to that programmer is as simple as going from that state to what camera you want. And you hook them up. And then we've got this little blend thing here that says, okay, if I'm in free look, normal, to the free look sneak, which is what I'm going to show you, I want you to take this long. And from sneak back, take that long. So then what you do is you just take your free look, which is here, and you copy it. And you modify this one. For those of you who have played Gears of War, there's like a roadie run. And it gets low, and it's super wide angle, and it feels really fast, and it's got camera shake, and the post effects change. It's awesome. So what I did is you just duplicated that free look camera. And like on a mixing board, we've got the solo button. You just hit solo. Dink. And we've soloed to this new camera. And this is so you can tune it. And I've been obnoxious. We've got some handheld on there. Way too much chromatic aberration. I mean, these are demos, so let's be silly. Okay, so that's what that camera looks like. But I've mapped that camera to sneak. And the sneak state is what happens when I press the B button. So now, while the game's running, we made it also work so the game's running. When you blend from run to sneak, you go to this camera. Thank you. That's the walk down the hallway removed right there. So that's my record is 21 free look systems for a character's locomotion system. And that wasn't me like, oh, what's another one I could do? It actually was 21. Running, standing, jumping, 5 enemies show up, 10 enemies show up, going inside, going outside. You can see where it goes. And you just layer it up and layer it up and layer it up. Because really good cameras can super reinforce gameplay. Which is, I'm going to get a t-shirt of that. It's mildly obnoxious, but it's true. So new to this free look, what we've done is we've added a couple of things. So we've added this thing called look ahead. Now what we do is we plot the path that your object has taken, and then we look at that path and we predict into the future. And we try to guess where your character is going to be. And I'm going to go too far, and it's going to look a bit janky. We've got it on each camera too, each one in the orbital. And then, let's just turn this on. Oh, I did it on the wrong one. Look ahead time. Look ahead time. We'll do one more. Oh, was that the last one? I missed the top one. Okay. So you can see we're targeting around his root there. There's the little yellow dot. But when we start to run, the system looks at where he's been, and we're predicting into the future. And now I've got it cranked up right now just so you can see it's a little bit jarring going back. But what's really cool about this is you get this stuff. Instead of the character looking like they're just in the middle of the screen and they're pivoting on a pole, you can have a little bit of a look ahead. And when you combine that with a little bit of horizontal damping of the composer, you can get a pretty good feeling free look. And then building on that is we've added a decoupling between the entire free look rig and the player. And I'm just going to crank that up. And what that does is that lets the character get ahead a little bit. And it goes back to those 3 pictures of heavy cameras that I was telling you about. Now you can go too far with this, of course, and it will be super annoying for people. Okay, so what I've done is I've added a little bit of dampening on this. So there's just a little, that little bit of decoupling. It's still a bit too high here. And then when you stop, the camera kind of crouches up, and when you go, he sort of gets away a little bit, and it's just not so robotically linked. So that helps. Now, the next thing I'm going to show you is a problem that's been plaguing us for a long time, and that's camera collisions. Camera collisions are a really hard problem because the scenarios are so variable, like something got on the way between the camera and the subject. You've got, vehicles or cars speeding around. You've got all these different things. I should have put a shake on this one. That would have made more sense, wouldn't it? Okay, so what I'm going to show you here is our new collision system, and we have spent a long time on this. Okay, let me just turn this look ahead time down. Has anyone in the audience worked on camera collision systems before? Yes, okay, good. They're hard, right? I mean, ultimately it's an unsolvable problem. You can just sort of solve it sometimes. Okay, so here we go. I'm just turning this look ahead time down. So I'm going to open this up. You're going to see we have this building right here. Now, as easy as going to any camera, I've happened to actually put it on the state-driven camera parent. So this state-driven camera, these are the children cameras. You can put all the logic, like collisions, you can actually put on the parent. And this is the collider script. You can say collide with different layers. I'm going to just say everything here. Preserve the line of sight. And then we've got different strategies. So in this one, I'm going to say preserve camera height and how much I'd like to preserve that height. And there's a little bit of damping. And we even have this shot evaluation thing, which I'm going to get into. And this is where it gets super fun, where we actually evaluate shots based on their quality. So I'm going to go in here. And let's see, even go in a little bit more. Now when I swing the camera around, I think I'm going to have a problem right here. So what happens is, see the camera come into the wall? Now, some of you are going to be going, whatever, doesn't all games do that? No, they don't, and that's a really hard problem. And what this does is it means you guys don't need to worry about this problem. You just get camera collisions as easy as going, I want camera collisions on this camera, and you can tune a few knobs based on, if you'd like to preserve its height. So here, let me show you the difference between those two. Preserve camera height, you can preserve camera distance, and then what it'll do is, this one's a bit crazier, but you can see we're trying to figure out we're trying to preserve the camera's distance between the subject, and it's actually really hard. So we actually are tracing multiple routes along the wall to try to get that. This one's a little less commonly used. I'd say camera height, or you can just say pull it forward. Just pull the camera forward. I don't need to keep the same height. And you can see we just draw a ray between the, we just basically push the camera down its head to keep it in line. Okay. Is this fun? Is this too much detail? Okay, cool. All right, let me remember where I put this thing. Okay, just a sec. We're gonna go into here, timeline. Where did I put these timeline objects? Okay, so that's on the timeline. Where did I put you? Oh yeah, derp. Here it is. Oh, Shiza. I might not be able to show that. They came unhooked. Let's see what happens. I had this other little bonusy thing where when you run to this trigger volume, we blended from a free look to, oh yeah, and I set this all crazy too. Let me just fix this. Yeah, okay. There's a chance this might not work. Let's see what happens. The trigger volume called the timeline called, yeah, the timeline. Oh no, here it goes. So what this is you can see this is a trigger volume here. The trigger volume plays a timeline. The timeline starts playing cameras which are on a Dolly track. They're changing their composition and blending back and forth, and then we blend back to the free look camera. And it's a pretty rough demo, but what I wanted to show you here is the ease of being able to put a volume in your world, have the volume call a timeline, and then you put different camera behaviors on a timeline. So if you have like a big boss battle somewhere, or you need to walk along a narrow little bridge or something, you can swing the cameras around and go to completely different camera systems. Cinemachine doesn't really mind or care. It's designed to work with every class of camera. So we'll see that again. We go into here, trigger volume, and then that blends to a Dolly track that's following, which blends to a camera that's more tightly composed on the guy. We'll hold that for a second, and it blends back, and then we blend back to the gameplay camera. And you can set this stuff up in minutes. There's some cool games that would benefit from that stuff. Okay, what do we do? Go damping, look ahead. Okay, let's go to Neon. Buy a little mouse. So we saw this at the keynote. I mean, this scene was, Vasa's got such great eyeballs. I wanted to show a few of the new post-processing mixing features in here. We've seen this video. You saw it at the keynote, so I don't need to get into it too much more. Actually, I'm going to kill this Unity because Neon's a bit of it's a big project. Okay, so this scene has post-processing stack version 2. I got a link for it at the end. Take a picture of the screen. And what I want to show you here is just how easy and quickly you can work with multiple cameras to create like really rapidly prototype shots and not do much animation. So in this particular one, I wanted a kind of a pan up from the floor shot and decided to target his feet and just let his motion pull the camera up. And as he walks, it tilts. It's a little bit dark on that. I'll turn these guys off. Or in this shot, we're targeting the center of his back. And all I did is I just blended the composition over just a little bit and back. So, just to kind of tilt to see the other guy walk by. This has just got a little bit of handheld noise on it and did a rack focus. In this one, this is a good example. There's no animation in here. So what I'm going to do is I'm going to just show you these two clips, which I'm butchering. Let's try that again. We've improved the clicky draggy of these clips, by the way. because they can be a little fussy. So look at this. We got 2 shots. We got this A shot here, which is really close. And we got this back shot. And this is, I put a little Dutch on it. You can see there's this little tilt. We got Dutch. And compose his neck. And we've got these post effects on it, so we can like, I don't know, let's make it do this for this one. This is pretty crazy, but just for giggles. And then we got the front shot. Oops, sorry, here it is. And then this is a camera from back here. But you just overlap them. I'm going to zoom in a little bit and see this. And this is timeline blending everything. And actually originally had it from the back to the front. Now we're going to pull back. And there's no animation. You're just blending clips. And Cinemachine clips are just ideas. And they're an idea of composition and a bit of noise. And the post effects, and we blend from this like bluey, like let's go too far. Like let's do, let's crank some aberration up and put some bloom on there. Am I the right one? Okay. And it goes back, and then your creative director would say, no, push in. And you're like, oh man, I got to change all these keyframes. It's like, no, you just flick the clips around. And I'm just putting that shot after and this shot before. You get where this is going, and it's just going to blend. And you block out these ideas. I've got an extraordinarily grippy, someone sprayed this table with like 3M make your mouse work horrible spray. Look at this. Sorry about that. Okay, so now we've got this back shot, and then pushes in. These are ideas. You just mix and match, and you'll blend them together. And this shot too, like the bit I'm trying to get. I mean, am I beating a dead horse here? You don't animate cameras that much. You tell them what you want to do. You tell them how you like to frame something, and they get the shot for you. And if animators come in over the weekend and they change the scene, you come in to work on Monday, your cameras are still pointing at the right things. I have a story of, I worked on a homeworld project, Deserts of Kerak, and we had a lot of procedural vehicles. And literally over the weekend, the designers came in and they changed the speeds of all the vehicles by 15%. Like that would, trash all your cinematics. And it was. I had to fix a couple, but it was basically fine. Okay, moving on. We've got this, and it's as easy. Look at this. You just show, like, mute the tracks. And this is follow zoom. So, have a look at this. Here's a Cinemachine camera. It's a clip. The clip goes to, here's all the properties. And then we have this thing right here called extensions. And these are extra things you want to do, like the collider that I showed you before, confiner, which keeps the camera inside a volume, post-processing, and I put a follow zoom on this one. So this is what follow zoom does, is you say, okay, I want to track whatever. We're tracking this guy's head. And I want it to be this big on screen. Let's just get a nice composition like that with, the umbrella nicely in frame. And then I'll have a little damping. I don't want the lens to get any more telephoto than 3 degrees, and I don't want it to get any wider than 60 because, that's pretty crazy extreme. So watch this. As the guy walks, it's always going to stay that size. And we're evaluating the size of this guy, and we're dynamically adjusting the zoom. So you're always getting that composition. So you can put follow zooms on your objects. Now, I'm going to just turn it off, just so you can see. I'm going to just, actually, no, here, sorry. Let's do it on the main camera. I can just delete that, guy. Turn it, and hide it. And look, he was that big. and then he'll walk by and he'll get, that's a nice shot, but I mean, we're trying to force a composition on something. And where this goes is you can set up like dialogue scenes, and you might not know where everybody is, but your head sizes stay the same between cuts. Speaking of dialogue scenes, I'm going to show you some nested timeline stuff. So these are different timelines, right? I've got them here. This one is called cinematics, and that's just what I've called it. I'm going to turn the follow zoom back on. And here we go. So there he is. Stays the same size, that's awesome. Now I've got another timeline called conversation. Let's have a look at that one. Okay, it's these two dudes here. And we got some shots going. Little master shot, jibber jabber. We cut to an over the shoulder. Then we cut to another over the shoulder. And cool, great little conversation scene. One timeline clip, those three ideas in it. For the master shot, I wanted to compose between these two guys' heads because, you kind of want to average it out. So we have this thing called the group target group. And what it lets you do is it lets you put in as many different objects as you like. So you can see I got one guy's head here and I got another guy's head here. And you've got the weight. So you can put multiple objects in there, and it's going to create a center point between all of your different objects. And through code, you can, where's the target group? Through code, you can adjust the weight, or you can adjust it here. I want to look at him, I want to look at the other guy. And this is really cool if you've got like a game with like tons of objects on it. So I just said go in the middle of the two guys, which gives you this point right here, which is also a nice thing that you can focus on, because with the post-processing stack, we get this little button right here. And without it, you just have some random number, and it's focusing on that. But when you say focus tracks target, it looks at the distance between the camera, gets that number, throws it to the post-processing stack, and says, the dudes are 4 meters away, or whatever it is. Okay, so cool. We got this little conversation scene. And then remember our little cinematic scene, which was the guy with the perfectly sized umbrella the whole time. Now look at this guy. This is a control track. So this is yet another timeline. And this timeline calls other timelines. So in this timeline, I've got a track, and this is the conversation timeline. And then the next one is the dude with the umbrella timeline. And what this is really cool is you can mix and match your cutscenes at a really high level. And it's like, no, put the conversation scene after the umbrella scene. And you're like, sweet, okay, no problem. We're going to just move that over. We're going to start with you get where this is going. Now, these don't blend, because like, what the heck would happen if you're blending these things? These are like, so now we start with this, and then we cut to the other one. So this is like a meta timeline manager. All right. Okay, this gets crazy. You ready? This is fun. We showed some gameplay tools. These are cinematic tools. This is now a space in the middle. And this is something that we've been working on. And we don't really know what we're doing. I mean, oh no, that's not it. We know this is cool, but we don't know, actually that's not true, it's cool. So check this out. This is one clip. And this clip is called a clear shot. And it has multiple children cameras in it. You can see them all down here. So you can take any camera from your project and you throw it in there, you make a list. And then you say the priority, like which one's more important. And then on each of the cameras, we do a shot evaluation and we determine how good that shot is. So what happens is you can do stuff like this. I'm going to just show you and pull this down. We don't need to see all this. So it's pretty dark. Can you see that? Do you have light controls there? Could we turn the lights down just a little bit if that's possible? Well, it might help a bit. This is quite dark. Thank you. Okay, so we are seeing 22 close track. Okay, so look at this. Yeah. Always remember to pin your timelines. So we have this guy who's walking. I'm going to just play it once and then we'll see. We'll watch over that. I've peppered the scene with cameras. And I said I like some shots over other shots. And I tend to like the shots that are really telephoto and kind of far away just because I think those look cool often. So we've got this shot that's pretty close because no other shot works. And then this little guy walks into a hallway and this shot is okay. But then as soon as he's covered up, and I'm not editing obviously, we have this extraordinarily dark, we can still see it. And then as soon as he gets in view of another camera, we cut to that camera. And part of the shot evaluation is not if the shot's good or not, but you can say at what distance you ideally want the shot to be. So for example, I'm going to just hit pause here. I'm going to open one of these guys. This camera, I really like it when the optimate target distance is 10 meters. So if a clear shot of this guy comes in around 10 meters, the priority of that camera goes up. Now this is a pretty rough demo. It's just a guy walking down in a straight line in a pretty busy world. But what I want you to take from this is you can build semi-procedural cinematics of things that are happening in real time. So you got a driving game and you have a car crash. You can make multiple timelines, multiple cameras, and they all have clear shots, and you're always going to cut to a shot that's good. Even there, you see that cutting's a little bit fast? It's like, oh, I actually don't like it to cut that fast. I'd like a activate minimum duration, let's say 2 seconds. So the shot has to be good for 2 seconds before we'll keep it. And think of, I don't know the projects that you guys are working on, but for replays or for procedural cinematics of variable scenarios, you can get some pretty neat results with that. Okay, we're going to move on. We have some friends of ours at INRIA, and it's the French Institute. It's like a graphics research facility in France, and there's a few PhD students who've been using Unity, Timeline, and Cinemachine in VR. And watch this total craziness. This is the set from Back to the Future. Place cameras, so these are like a little interface on the control. This is the guy. So the ability to, blacksmith guy, right? He's in Back to the Future. IK, so you can bend it and sit him down. Move the hands around. Place objects in the world. These guys put a little T, here you go, thirsty. All right? But this is where it gets crazy. So that's a Cinemachine camera. They're putting in the world. This is the Cinemachine Dolly track, which I haven't showed you yet. It's just like a film Dolly track, and the camera sticks on it. Bending the Dolly track in VR in real time. And then this is the bit that just blows me away. They follow an actor. So you pick a camera, and then you pick a character. Cinemachine spools up. Make the camera look at the actor. And then you get the shot. And then you now have procedural composition. The camera's on an auto dolly, so as he moves, the camera's going to follow it. And you've created this like virtual Cinemachine. The characters are animated with timeline. I think for a single person, this is probably a bit of a ridiculous way of working. But imagine multiple people like sharing the same environment. Like your DPs in London or whatever, and you can all share the same virtual space. yet do some, do set design and block cameras out. That's pretty cool. Okay, we're going to go to one more scene. Go away. How's everybody doing? Is this fun? You like this? Okay, good. Yeah, thank you. I always wonder, you do this stuff. It's like, you don't like this? So I'm going to load up the Atom V1 scene and show you the Dolly track that's in there. It's a really fast, powerful way to get camera behaviors. And I hope it's loading. How many people have gone to, how many people is this their first Unite? Oh, awesome. Okay. They're a lot of fun. I hope you guys are having a great time. There's so many amazing talks, like you just can't hit them all. Okay, so I'm going to show you one more thing, and then I think we're good. So sorry, I need to turn my brain into this. Where am I? Come here. This mouse. Okay. So, got a little Atom guys walking around. So I'm going to turn this down, and we're going to go to the Dolly track because it's fun. So doing smooth cameras that follow things is kind of tricky because often what you have to do is you have to either have to put the camera as a child of the object. And if you've noticed here, the cameras aren't underneath things. They're not inside the scene. They're always outside. You don't put cameras under the hierarchy of anything to impart their motion. What you do is you just say, hey, camera, follow this thing. So follow this guy, and then here's how I would like the follow to work. So this is a tracked dolly. There's multiple different follow methods. And what this one does is it's going to keep the camera lined up with the subject. Sorry, I lost my guy again. So let me show you what I mean by that. Close these guys. Okay, so auto dolly. So you can look here, we got this crazy dolly track, and you can adjust it in, if you don't have a mouse that is soul destroying, you can select it. Let me just do it manually. You can grab the little points, got nice little tangents, and you can make your own dolly track. And then what the follow does is it lets you have an offset, and you can go behind or in front. And as that guy moves, got a little bit of noise, which is why you see it wobbling around. Let me turn that noise down a little bit. Oh no, I don't have noise on that. Oh, I've got too much damping on it. The camera will follow. And for games like Crash Bandicoot or any kind of trough game, no matter what the character does, that camera is going to follow. And if you want it to go a little bit ahead, a little bit behind, oh no, sorry, that's the wrong one. Or change the composition, change the lens. That the camera's going to follow it. And you can adjust this stuff. And the bit that I mentioned in the keynote, but it's applicable here too, is all this stuff stays in play mode, because you're going to do this stuff and you're going to be like, get to the end of the level and be like, oh, okay, I just want to make this dolly track go higher, or change the lens at the end for whatever reason, or you get it. You make all these changes, you get exactly the shot you want, you get out of play mode, and it's all saved. So we're at the end. I mean, we've got a few minutes for questions, but thank you for coming. Now, two more things. So, Cinemachine's free on the Asset Store, but I mean, you can get this one. Post-processing's free on the Asset Store. Oh yeah, this is my totally pretentious, wanky, but super true. Everything you do goes through a camera, so get that thing right. Like everything goes through. You know, a hand of 7, 8 transforms, right? It floats. You know, like the camera's such a small little thing, but it's the window to your world, so you got to get it right. Take a picture of this if you're interested. The link at the top is the Atom project that I showed you with the Dolly track. The next link is the latest Cinemachine that we're about to release with 2017-2. It's in a release candidate. It's got a ton of stuff in it. The middle one is audio scrubbing and timeline. That's something that we haven't folded into the main line, but it's something that you saw the keynote. And if you're doing like cuts on beats or things you want. And then the last one is the version 2 of the post-processing stack. Now, you might wonder, why do we have things that are on the Asset Store and are here? And the answer is we have a central system coming, which is going to be called the Package Manager, and it's going to handle all of this stuff. Getting technology into the main Unity is a pretty big endeavor, and Unity's pretty huge. So we're incubating ideas on the outside. Sometimes they live on the Asset Store, sometimes they live on GitHub. And when they get mature enough, they'll come inside, but they're going to come inside not the main Unity. They're going to live in this thing called Package Manager, which rolls out at the end of the year. So for now, this is a little bit lumpy, but it works, and this stuff's great. So, and it's free, so grab it. Oh, and if you want to follow me, I talk about new features and stuff like that. So yeah, thank you. Questions? You got up first, so you win.
All right, thanks. Thanks for the talk. I wished I knew a little bit more about cameras.
Okay.
So don't have time for film school.
Yeah.
Would love to. And I know that the way I would end up doing this is manipulating every single one of those million sliders that you just showed until I ruin something and then try again. Is there any plans in the future for some camera education for us developers?
It's a really good question. I mean, we're in discussion with a couple of film schools to work with them to, you know, they're doing traditional film theory, and we've got like camera gizmos and, you know, what the middle part is. I'd love to teach a course on cinematography, not that I'm the world's greatest expert at it, but I've been doing it for a little bit. We don't, but I think what's going to happen next is we're going to do really good, we have some now, we're making more really good tutorials on the Unity Learn site, and they get you up to speed, and it's like starting from zero. We've got one now on YouTube, which is like, I don't know anything about Cinemachine and timeline, and it walks you through the process, and then you'll be on your way.
Okay, thanks.
You were next.
Yeah, hi. Thanks for doing this, by the way. That was really cool.
Thank you.
The question I had was, the way you have the camera set up with the targets where they're following the objects, do you pre-set up the camera to be pointed at that object and then do the follow, or does it, like, how does it know, I guess, to be pointing the right direction? Like when you had the mouse, how did it know to not be behind it initially?
Right. Okay, good question. So you pre-configure cameras with their targets, and then the cameras spool up and then display, so you never see that. Actually, we've had that bug, but that doesn't happen. So the cameras are pre-warmed before we show them. You can also dynamically populate the targets through a little script. So if you wanted to, you know, assign a target at runtime or change it, that's fine too. But the cameras don't display until they're ready, and we spool them up really quickly before they're shown. Okay. Did that answer the question?
Well, I guess when you're setting up your scene, like you had that tight scene from the keynote yesterday.
Yeah.
You must have pre-positioned those cameras before you started, you know, actually, I guess, filming.
That's right. Yeah, there's no magic, like, throw all the cameras in the scene in a beautiful way. Like, I went around the world, and I'm like, hey, that looks like a nice shot. And put the body in, and if the thing was moving, then I set it as a target, and went through. And we had some tutorials on the Learn site that show you. I mean, I'm going to do another one of that, just building this stuff. And you can just see how you just, like, get in the world, look around, like, okay, that's cool. Throw a camera, target him, tune, okay, done, next one. And you can, like, it's handful of seconds per camera to throw them down.
Okay.
And then once they're on those clips, then you can like, hey, no, put that shot ahead of that one, or blend these two together. I mean, it's fast. That's the whole point.
Okay, cool. Thank you.
Hi.
Hello. I was wondering, like, how did you choose which aspects of physical cameras or lenses to incorporate into this and which to, like, leave out?
That's I mean, we should go have lunch and talk about that one. That's huge. Great question. The ones that we did were the ones that were the most commonly emulated things like vignetting, chromatic aberration, those lens types of things. The ones that we didn't include are the ones that are so true to life that it's actually a pain. Example, exposure. If you're actually using a real camera and you want a certain aperture because you want a certain depth of field, then you start to paint yourself in a corner. You've got a shutter speed you can change, and then you got your film ISO to change. And we didn't want people to go, like, we didn't want to get so physical that you're like, I need, I'm going to get all this film noise because I've cranked my ISO up to get the shot that I want. So that we just said, okay, it's a game engine, we can do whatever we want. But we at least gave you the controls for the creative aspects. And back to, that shot, this one, like you can do dumb stuff. Like we try to help you not make mistakes. Not that this is a mistake, but I mean, when depth of field sliders are completely decoupled from everything, you can do this. And I don't think people want to do this in CG because the reason why this looks amazing is because it's real life. If you do this in a computer, it's just like someone didn't know what they're doing with depth of field. So we're trying to keep guardrails on so people do the right thing most of the time, but of course you can go past them if you want and do silly things.
Thank you.
It's a great question. Thank you.
So I wanted to pay you a compliment and then also ask a question. I think the
Okay.
thing that's really awesome about how you guys build these tools is that you look outside of games into the real world where people do these jobs professionally. I think it's amazing that you focus so much on kind of facilitating people who are outside of games or making games more real world like. So thank you for doing that.
Yeah, thank you.
But so I have a question. I'm currently using the post-process stack version 2.
Yeah.
And I haven't dug into Cinemachine as much as I'd like to.
Okay.
Are there any issues with compatibility between versions of like the post-process stack and Cinemachine?
No.
Or Cinemachine, they all work together?
Yeah, so we detect, and if you're using version 1, under the hood, version 1 post-processing stack. With version 1, there's no blending. You can cut between different profiles, but you can't like blend. In the keynote, I went from color to black and white on a shot. You can't do that in version 1. That's just a post-processing stack limitation, but on version 2 you can.
Okay, so and then related to that, do you have a plan that involves a lot of major revisions to the current state of post-processing in Cinemachine? Or are those kind of locked in enough that we can implement it in our projects and know that we'll keep being compatible moving forward?
Yeah, so post-processing 2 it's on GitHub, so it's still in development. I know people who have gone and they're using it. The answer would be, I mean, that's not my team, so I don't totally want to speak for those guys. And if they're watching this video, hi, Thomas. I would say it's okay to use, but realize that it is a GitHub project and it's evolving. The evolution that they're doing is like performance improvements and bug fixes. So I don't think you're gonna have a backwards compatibility issue where you really, really don't like doing that. Cinemachine is for compatibility. We had to break everything between version 1 and 2, so nothing came forward. We never want to do that again. My answer is go for it.
Okay,
Yeah.
thank you so much.
Cheers.
Hi, thank you again. This was great.
Thanks.
Two very quick questions. The
Okay.
first is kind of the next direction on the Cinemachine side of things
Yeah.
in terms of like, is this the core of it? Is it going to expand more in the interactive side of like, colliding with walls and handling stuff like that, or more adopting traditional cinema things into the digital side?
Yeah.
And then the second question was, does this also work with ARKit and things like that?
Right, awesome question. So we have collisions. We've been working on those. Those are going. We showed them a little bit here. Both. So the next step that we're doing is we're improving the physical camera stuff. So that's going to get even better, and that's on the cinema side. Most of Cinemachine is actually for gameplay. Like we always do these splashy, cinematic trailers, and it's only using like a quarter of what Cinemachine really is. Most of it's gameplay stuff. So the stuff coming up next are impulse camera shakes for rattles and camera shakes based on what's happening in the game, dynamic systems for that, and just more gameplay features. And the AR stuff, that's a really big question because your head is the camera in AR. But what we're working on next is 180 VR, because 180 VR, you can actually bring some of the lens language forward because you can do stuff like cuts. You can spool up and look at something. And 180 VR, I think, is going to be really big because you're not crashing over your coffee table, and you can actually wear it for, more than a few minutes without going, that was cool, but get it off my head now.
And
So.
I forgot one last thing about
Yeah.
the first part, the interactive side. Are you expecting to do the same look ahead for like player camera navigation as well as player avatar navigation, so that you don't just like have the camera jump when it runs into a wall, but so it can like dodge it before it gets there?
Yeah, so that's a really good question. That's a hard problem. And we've looked at doing some nav meshy type stuff so the camera can get out of the way of upcoming things. Really fascinating problems, kind of expensive. And right now it's just a bunch of whiteboard squeaking sitting on a wall right now. But we are talking about it, but I can't give you a date on that because like the problem gets hard really fast, and it's like a performance. And which we try to build stuff that's as game agnostic as possible because we don't know what game you're making, and you're making a different game, and you want to use this stuff. So we don't have an answer for that yet, but it's a good problem.
Thank you so much.
Yeah, no problem. Hi.
I wanted to ask about first-person camera rigs. I was hoping
I forgot to show that.
to see an example. Yeah.
It's
So you think
come
it's
chat.
well suited for first-person?
So we made this thing right here. Do I have it on this guy? POV. It's on the Composer, and it's our first-person camera rig. It's not crazy mature. We're still building more features on it, but it gives you, it's not going to work right now because I haven't quite set up right, but it gives you inputs. You can, it's a first-person shooter camera, but it's like a 1.0. We want to get into people's hands, get feedback, and then like we move fast. Like when we get features coming in, because we're not going through the main Unity, we just put it on the folder that I showed, the Google Drive folder. We come out with iterations like every day or two. So come grab me after this, and
Sure.
I'll give you my card. And I'd love to get your feedback on that. Hi.
Hey, so you talked a lot about the organic kind of component of this, of making it feel really natural, but just how precise and focused can you get? We're dealing with a lot of fixed aspect ratio content
Okay.
that we need to fit to a very wide variety of screens.
Right, great question. You can turn all that to 0, and then it's just like surgical math camera.
Laser down to, what does it actually focus on? Is it the geometry or collision boxes or?
So the follow focus focuses on the center of the object that you've say to target, and then you've got an offset in local space, but it's basically like if I say your foot model, it'll look at the center of your foot model, and then you've got offsets. But if you set all the dampening to 0 and you set the screen guides tight, it's like rock solid. There's no squishiness in it at all.
Cool, I'd love to talk to you some more about after this.
Sounds great. Yeah, let's do it.